Alexander. This will be controversial, by the way. You've been warned. Do we have any enterprise architects in the audience, by chance? Please, no violence. So any technical book starts with acknowledgments and inspirations. As you figured, one inspiration for this talk was John Bon Jovi. Why? Well, think of it. The guy barely graduated high school, and back in the 80s, he had enough foresight to envision the life of a DevOps engineer years into the future. And if you don't believe me, you just need to listen to the lyrics more carefully, because it's all there hidden in plain sight. Like, Tommy used to work on the docks, right? So that's how they called Docker images back in the days. Like, and that's a New Jersey accent. And so, like, we can infer that he worked in some kind of CI/CD, like build team, and then something changed, and his life became tough, like very tough. From the subsequent lines, we can figure out that probably there was a reorg in the company, maybe even layoffs, and he ended up on the DevOps team. So now he needs to go on call, and he gets paged. How do we know that? Well, Gina dreams of running away, she cries in the night. That doesn't happen if the pager duty just calls, like, wakes them up once, right? Clearly, this is not the first time, because it was once she'd be like, honey, what is this sound? Be like, oh, this is a PagerDuty app on my phone, I need to check what's going on. No, this has been happening for days and nights, and she knows, and she's crying, and he's like, baby, it's okay someday. So he's hopeful that they will fix the system, they will stabilize it, and it will not be paged. And so what's follows that is really the anthem of DevOps engineers. Like, if you experience firefighting in the middle of the night, when service is down and some errors happening, at some point, some people in the team despair and say, okay, it doesn't make any difference. Like, they're ready to quit, but then you persevere and you fight and eventually get through it. So, like, this is really the anthem of any kind of DevOps team. Back in my Microsoft days, I was given the project, the team and the service to run, which is one of the core Xbox services. And literally on the first day of me on the job, the service went down and stayed down for 8 hours. That was no fun. But also it was the very kind of low starting point for me on the job, because it cannot be worse than 8 hours down. Anybody knows who this is in the audience? Exactly, because the reason, this is Carly Jepsen, and the only reason she is here because she inspired Kyle Kingsbury to build his Jepsen tool, inspired by her song, Call Me Maybe. What Kyle did, he was bored in his apartment and he had a big beefy machine. He started running open source databases and validate, or rather invalidate, their claims about consistency. And he started publishing the results of his research with kind of funny references to the song Call Me Maybe, something like, you gave me data, I saved it maybe. And because it was public, first reaction was furious for all those vendors, because he would publish like, okay, FaunaDB 19 issues. Is it Yugabyte, TiDB, Mongo, look at it, Redis, 21 issues he found, like in one test. And like even in Postgres, he found an issue, it was there, a bug since version 9.1. So nothing was sacred for Kyle, literally. Like even Postgres, nobody should say anything bad about Postgres, but he did. So those are inspirations. The topic of this talk is streaming, right? And we need to start with definitions. And in our industry, as it's typical, there are multiple definitions of the same terms. Like this one says it's about sequence of events in time. Another one says it's a sequence of data elements. So which is it? Is it data or events? Are we streaming data or streaming events? What's the difference? Well, let's try to define what the event is. And so event kind of conceptually is a change of state of some entity, but we can't send a change. Change already happened. The event is a notification of some change like that. And some people refer to them as facts. They say we propagate, we distribute to the system immutable facts. This happened, this changed, and that's kind of what it works. But literally, like almost anything can be an event. Like a request is an event. Some client, some system requested some operation, and then the response is an event. The operation completed successfully, here's the result, or maybe it failed, here's the error. So like, you can decide for yourself, but in my opinion, almost anything can be treated as an event. And this is fine, because if you look at, for example, streaming video services like Netflix, it makes sense to use streaming, because even though the video file is finite and could have been downloaded and played locally, it's not practical because you don't want to wait and the device doesn't have space. You don't want to use bandwidth. You want to be able to use the right resolution, change on the fly, I guess keep forward, all of that. But there is still this confusion. What are we streaming? Data, events, what does it mean? And I'm guilty of that. I contributed a confusion, and I even shamelessly used a photo of my underage son as a prop for my talk. What I really want to talk about is event-driven architecture. And what is it? It's really about decoupling. That's the main idea behind event-driven architecture. So you decouple systems in space. They're in different locations. They're connected by network. But also, like, you have different teams operate. They have different responsibilities. The important property is that they decouple in time. Like, if I put message on the queue, there is no guarantee that the message will be processed within some bounded time. That goes and will be processed sometimes, maybe. This is where maybe gets in the picture, because we put it on the queue and hoping that it will be processed, maybe. But the key is really, like, behind all this noise about event-driven architecture is availability. Because we can put message on the queue even when the recipient or a processor for this message is not available, or maybe is going through upgrade or something else. We don't have to depend on the availability of that other system. And that enables evolution of the systems independently. But since we're talking about developers, the main question is, how do we program the system, distributed systems, really? And there is another inspiration of mine is Joe Armstrong. As you probably all know, he created things like Erlang and OTP and a bunch of other things. And without his contribution of making the actor model, which was kind of like a theoretical concept, more or less, put it into mainstream, and without that, I think there would have been no Akka. I hope Roland would agree with me. There would be no Orleans. There will be no Elixir and things like that. And so he was very good at promoting his ideas, going and talking to people, presenting in conferences, getting into arguments with people. He was like really like larger than life. He's such a big personality. And in 2019, I believe, the conference here was called Joe on the Beach, to really like celebrate Joe's contribution to it. And so, like, I respect Joe a lot, but I also had a disagreement with him. I think it's okay to respect somebody, but also have a difference in opinion. You don't have to agree on everything. And I had this debate with him, I think it was NDC Oslo 2016, where he presented like one-way messages. Everything should be one-way messages, send one-way messages. And I caught him after the talk and asked, like, Joe, what do you think about promises? Like, no, promises are bad. One-way messages, only one-way messages. And I posed this kind of situation to him, kind of hand-waving. So you have two systems, and one sends requests to the other, right? So we send 3 requests, and say we receive 2 responses. How do we know which responses for which request? Well, obviously, we know the answer. We need some correlation ID that we send with each request, and then the response comes with correlation ID. There is some map where they get mapped, and each response gets mapped to a request. And there is code for that. And that's what the promise effectively is. So we make a call, and then we wait the response, because all this machinery of correlation IDs mapping is done for us. So we kind of lifted developer experience programming model one level higher. Event-driven architecture also has this very interesting proposition of PubSub, publisher-subscriber relations, where the producer of the events that puts them on the queue doesn't even necessarily know who consumes at what time those events. It's a kind of very flexible proposition that these consumers, they can be added dynamically over time. They can come and go. They may subscribe to some queues, topics, whatever you call them, unsubscribe, and that kind of decouples systems even more. The whole architecture of the system, the topology can change over time. So it's all like sounds very good until you have to face the music, and you start seeing diagrams like that, like an enterprise service bus. Oh, we put everything into this kind of ether, and then we consume it. This diagram, I think it's already clear, was not done by a developer. It's probably done by an enterprise architect. And I have nothing against enterprise architects. I love them, especially as a vendor. They're very like helpful and useful. But there is a difference between kind of being a developer and being a high-level architect. Then you get to pictures like this, which is like, to me, gets to a ridiculous level. It says here, like literally in the description of this, so that these components with a set of switches that direct messages along a specific route dictated by the organizational business policy. Again, it was not written by a developer, probably not even by an enterprise architect, it was probably by a marketing person. But they say this is architecture of the system. To me, this is like not really applicable. So this is the realities, right? So we have this kind of enterprise service bus, like everything goes there. But we have this very loosely defined relations, like ad hoc dependencies. There's no like explicit contract because things change over time. I had a conversation a few weeks ago, I think it was like interviewing somebody, and we're going through the projects, and they asked, so why did this refactoring take so long? Like, I don't remember, it was like 3 or 6 months. It seems like it's a very straightforward thing you change. And the candidate said, well, you know, we were discovering over and over again there are some unknown dependencies, so we're trying to not publish messages on this topic, but we didn't know there are like many dependencies that already like emerged, and they needed those messages, and we tried to deprecate this. And so they had to build workarounds for every single case. This is real business impact. Those kind of high-level, very generalized enterprise service bus architectures. Because evolution is very difficult. Like if you want to change, you want to deprecate one thing, and it doesn't allow you to. So like, here's what we're dealing with. We have architects, again, please don't run to the stage, no violence. And we have like grunt developers that look at the screen, and by the way, Silicon Valley is a documentary, if you don't know. This is not a comedy, like it's a real documentary about how Silicon Valley works. And so there's like clear like divide between people that build these nice diagrams, they go to their business leaders, say, they sell them on this, but then these poor developers, they look at this and they try to figure out how they're gonna live, how they're gonna support the system, how they're gonna be cold at night. And back in 2001, Joel Spolsky wrote this famous post about if you go too high in abstractions, you become an architectural astronaut. And I like this term very, very much. I kind of use it semi-offensively several times. Because really, like, this picture is like this, right? We have these people doing the job, and we have these astronaut architects trying to open pod bay doors, right? They're dealing with a completely different set of challenges, detached from what these people are doing. It's a reality of event-driven architecture with all this enterprise service bus, all these architectures. It really boils down to that it's used for reliability. Like the picture where we send messages that I was arguing with Joe Armstrong, it's kind of the same, but instead of sending messages over the network, we send them over persistent queues. So it's the same kind of dynamic, right? We send requests, we get responses. But because we decouple in time, we cannot really use the simplicity of a promise anymore. Because are you going to block on this promise for minutes, maybe hours? Maybe it doesn't make any sense. Our process may crash. We may need to restart it, upgrade. So that programming model doesn't work anymore. And so like this reinvented thing, as always, like in our industry, all cool things were invented like in the 70s. Everything else is being reinvented many times. And of course, if you look at Phil Bernstein's and Eric Newcomer's book, this is the second edition. The first one was published in '97. They described this very nicely, concisely, how the queuing is used for availability, where client can in-queue request even when server is unavailable, and server can in-queue response when client is unavailable. So there is nothing new there. So that book is used as a textbook in many computer science classes, and the slide is from Phil's class, I think from 2007, but nothing really changed there. And so this kind of use of queues for availability leads to architectures like this. I think probably people will not argue that. You've probably seen this thing before. There is something, there's some Kafka, there's some topics, and then these pieces of software that consume events, produce events, we take it from this topic, we put it on that topic, and that's how applications are built, or systems. And it's not an exaggeration, right? This is like a reality. This is like a quote from one of the recent case studies where the developer wrote that in the system would have the worker get the message off of a queue, from some chunk of work, and then go and put the message back on the queue with the pagination marker to perform some other chunk of work. Do you really want to code this way? Do you really want to build a system like this and deal with this sort of chunk here, chunk there? This is another example. There's a shopping cart, there is some validation of sales, tax calculation. It's a similar thing, right? So these chunks of software that connected with these queues, with these pipes, and nobody really knows what's going on in the system, to be honest. Like, how would you figure out what's happening with the request? If there are chunks of messages on all these queues in a different state, and there's no visibility in this queue. And so we step back, kind of what we really done here. We use queues as this kind of reliability mechanisms that connect our pieces of software. And this is a simplified picture, right? Because there's only like 2 legs, but in reality, there is way more. There's like 5, 7, 10. And I think Alan talked in the opening keynote, the more layers you add like that, mathematically, probability of it failing because one of these things is misbehaving, it's guaranteed to grow, just like with the Scrum issues, right? And again, I stress here that when we put messages on this queue, we hope that all these downstream subsystems, all these downstream dependencies will process, really streaming these events on the prayer, hoping and praying that they will be processed properly. And maybe we'll get called back, maybe we'll get a response, maybe not, maybe we'll get the webhook. And so like another name for this architecture is duct tape architecture. Because we've like used this as a duct tape or a band-aid to solve the problem that we actually have of building an application in a consistent manner. Because again, we go to the issues, like there are no APIs in the system. You can't just call and get an answer back. You just put a message in, you don't know what happened. You don't have an immediate response to that. Maybe it's argument wrong, right? You don't get that. We compartmentalize or split our application to these chunks that are going to distribute it and kind of operate in this kind of semi-chaotic way. There is no like one place to go and see, this is my business logic. This is what happens when the request is processed. Instead, you have this 5, 7, 10, 20 pieces that kind of microservices that run and try to process something. And because of that, and because the system is very hard to evolve, like in reality, we got it even more tightly coupled. So we started from trying to build a decoupled system, but we end up with a very tightly coupled in this indirect way system, which, I don't know, I hope nobody enjoys building. And I'm not saying that event-driven architecture is wrong. No, what I am saying is that it's low-level abstraction. And we have other examples of low-level abstractions. So when was the last time you had to send scene and act a packet on the TCP? I would imagine almost nobody, right? Because we have high-level libraries. We can make HTTP calls, we can do request, we can do gRPC. We don't even think about going down to that level. Same with like assembly. It's a beautiful thing, very powerful. Nobody really programs until like they really need to. So how do we usually solve these problems? This is standard answer. We build better abstractions, and then we build frameworks, and sometimes even paradigms to program in a better way, to program at the right level, not at kind of where we lose oxygen, like astronaut architects, but kind of building proper layer systems. I will talk about one approach to solving this problem, but there are others. For example, there's a data flow approach. I'm just much less familiar with that. I don't want to talk about something I didn't really know well. So I'm going to talk about durable execution, which is a programming model that has these interesting properties. So it allows developers to write happy path-style business logic, where you write your code for what you want to do in the application, and you write it in one place, you don't break it. And how it's done is that the root of the problem is our interactions with other systems. That's why we send in messages. We're talking to another service, another API, maybe the database. So these interactions where they go outside of our process, outside of our memory space, where we lose control, they're defined as explicit actions. And so the reliability of execution of these actions is done by the runtime, by the programming model, by the system. That's how we get a resilience of their execution. Another kind of unrelated but also very related feature is that time is a first-class concept there. So it's totally okay to say, I want to wait for 30 days and then do something as part of my business logic. And as a result, because kind of timing is not a problem, we are not really dependent on anything like within a process. We get this business process that can run for a long time or forever. They're not attached to physical machinery, the physical like, memory. They cannot run, it can be forever if we want to. So this is like a pseudocode version. So we have like a business logic that needs to do these 2 steps and sleep for 7 days. And that's a real example where we provision a new user account. So we provision an account, we give permissions, and then want to sleep for 7 days and see, did that new user do something in the system? Because if they perform an operation, we want to send them an email with some tips and tricks after 7 days. But if we discover that they've been silent, they've not used the system, we want to send them a different email and say, look, you haven't used that, here's how to use it, or some kind of, nudging email to them. And so with durable execution, first thing that happens, we record the request. With arguments, the request arrived. That means that this process can die, we can restart, and we can continue execution because we know all the arguments. And that happens with every step like that, where we leave essentially control of our process. We record what the API want to call, what arguments we want to pass. If it fails, the system will automatically retry. We don't write any code for that. And then when actions successfully completes or maybe fails in terminally, not in a retriable way, then the result is also recorded. And that goes for all these kind of steps that go outside of the system. In between them, there can be a local code that does local operations because that's fine. There is 100% kind of guarantee we're in control of that execution. And then we can say sleep for 7 days. We're not going to use resources. So this can be, this process, business process can be evicted from memory, which is fine, and then rehydrated later, 7 days later. Why? Because all execution has been recorded. We can load it, and then instead of calling those steps, we just get their outputs and re-execute our code. So kind of we replay by cheating without going outside and repeating steps that were already completed. That's how we can reconstruct, rehydrate this process anytime we want. And so that's kind of the gist of it. And again, if I step back, in most critical pieces of every application, there is business logic. This is what actually matters for business. There is state management, which is a fancy word for data. We need to read data, we need to write, we calculate some variables. And then there are these steps of integration where we go outside of our process, where we need to call other systems that may or may not be available, they may give us errors, they may throttle us. And all of this is kind of surrounded by the need of handling errors, failures, all of that. And so this code is always intermixed. And that's why we started calling this, like if we take the analogy of fruits and vegetables, we get like a big blender machine, and we create a smoothie out of all of these components. That's what we call a smoothie architecture, where all of this is combined. And then if you want to replace business logic, I want to change my business logic, I have to find all the pieces of strawberry in this example and replace it with cherry, which is obviously like very difficult task to do. What we want to get is kind of layered cake architecture where we have all these concerns separated in layers, so we can take and replace just our business logic. And if we look here, we go back, there is nothing about state management. There is nothing about handling failures here. It's only like business logic. All these integrations are factored out in explicit steps, and they're written separately. So essentially, we get this layer cake architecture through this programming model. Because everything is recorded, we also have full visibility into history of execution. We can go and historically look, what happened? What was the timing? What was the response from this action for this request? We can also look at live things. So if something is failing, we can see, okay, we keep retrying, it's like 4th attempt. And the next retry will be in less than 4 seconds. Like, try to do this in normal program where there's some process, you can attach a debugger, but that will essentially kill your application realistically. And so, durable execution is not a new concept. The first implementation was done, I think it was 15 years ago at AWS in terms of simple workflow service. And so this is kind of main lineage of the systems that were built. But in the last few years, it became more and more popular, and even like upstart solutions that try to rethink and approach it differently. They try avoid this kind of replay recovery mechanism. They want to try to do like WebAssembly style checkpointing. We'll see that works. But they all contribute to this kind of moving from smoothie architecture to layer cake architecture. They all align on the goal. So this is my mental picture, that event-driven architecture is kind of plumbing underneath, and we want to build application at the high level that doesn't have to touch this plumbing. And this plumbing is handled by a programming model that is developer-friendly. But like I said, I give one example of that. There must be other examples. And another kind of depiction of that I like is like this is view of the solar system with the Earth-centric view. It's not incorrect. Technically, it is correct. But it's very convoluted, very complex, very hard to figure this out. And then Copernicus came and said, hey, this is sun-centered solar system, which is much more obvious. It's the same thing, right? But this is much simpler. And that's kind of, I say, this is event-driven architecture, and this is durable execution. Works the same way, but you choose which one is more convenient for developers to use. One more problem. Long-run operations. Again, if we take the same picture, that same diagram discussed with Joe Armstrong, what happens when we make a call and that operation takes maybe seconds, maybe hours, maybe days? It's interesting that within our industry, still there is no standard for that. There is no standard API how to deal with these operations. There are some kind of local balkanized attempt, like Google has like a long-run operation, Microsoft has some kind of prescribed ways, but there is no standard like that. And so like, there is a bold proposal to solve this with this guy, because we need a replicant, somebody like really resilient to solve this problem. And it's the project code named Nexus, which has a very simple proposition. It kind of like very much inspired by REST, but now taking it to this long-run operations, which defines start, which obviously start an operation. That's a post call, and it may return 200, meaning it's done. It completed in line, synchronously, here's the result. Or it may return 201 and return operation info structure, which has ID of the operation. They can use later to call result or info. You can kind of call the state of this operation using that ID. It's returned as part of operation info. But you also can optionally pass a callback URL and say, when this operation completes or fails, call me here. So it's like a webhook built in optionally. And of course, there's the cancel to try to cancel it if needed. So it's very much like REST-inspired, HTTP, nothing fancy, no enterprise service bus, no enterprise architects, very simple. And this is like what URLs would look like. You have a path that has a service name, like in this case, payments, then operation, transfer, my example. And then for start, of course, you need an ID, but for subsequent operations, you need ID to hold them. We'll see. Like maybe this will become a new REST, or maybe more logically be an extension to REST to support this kind of operations. So like, where do we go from here? Well, I could go like Bonnie Tyler on you and say like, I need a hero. Like, I'm really holding up for here because some of these things can be done by like one dedicated engineer or some small group that really go and push the boundaries and kind of question orthodoxy, like Kyle did. Like he's like showed like all of your guarantees that you described, they're actually not there. Here's the better way to test for that. I already like mentioned some of my heroes, that it's just some of them. Here's like two more examples. Like remember in early 2000s, there was like all like web services, there was all the rage, like SOAP. Microsoft had this like big team, the project codenamed Indigo, that produced this WCF, there was WS standards. People are meeting and building all kinds of standards and diagrams, very much great for enterprise architects to discuss all this beautiful architecture. And then Roy published his his PhD thesis, and he promoted this model that suddenly took off. And I was in Microsoft, I saw that happening. Like, WCF just released like 2 years before that, and they're like, customers don't need that. Just want REST, and WCF didn't support REST for a while. Like, one guy can come and completely change the game. Well, I mean, Diego Angar doesn't need introduction. I believe he was already mentioned in a couple of talks at least at this conference. Because again, like with his thesis on Raft, he changed the game, and now I would guess probably at least half of internet runs on Raft, probably, maybe more than that. Notice that the heroes, they tend to come to Jay on the beach. Just somehow they attracted to this place. The Malaga is a magical place. Exactly. So I could go Bonnie Tyler on you, but actually I'll go full David Bowie. We can be heroes. Like, this is the picture from last year. Like, all these people like in the room, I think it'll be even a better picture from this year. Like, anybody here in the audience can go and build this stuff. We have all the tools we need. We have internet to communicate, collaborate. We have GitHub, we have open source. We can work the way that was not even possible like 20 years ago. We have these laptops that are way more powerful than what we use for. We have all the resources. We just need to dare and try and build new things. So like, we all can be here. You can do it. Like, all can do it. So let's try. Otherwise, muchas gracias. Thank you very much. Danke schön. Merci beaucoup. Tak. Спасибо.